There's a really easy trick we can do. Check which interfaces that it implements, and we make specialized widgets for every interface. We can detect if it's an NFT, and we can make like a really nice NFT experience. We can see if it's an ERC20, and we can build in the like swap router experience. We can check if it's a DAO. We can check if it's like an ownable contract. We can check if it's a proxy. If it is, we can give a little UI for that. We can build all kinds of really streamlined widgets. It doesn't have to be as raw and as dumb as Etherscan is.
Scraping Bits is brought to you by the following sponsors. MEV Protocol. Maximize your ETH staking value with MEV ETH, exclusively on mev.io. And Composable. Execute any intent on any chain, coming soon to mantis.app. That's mantis.app. And Fastlane Labs, the only MEV and intent-centric team that has a daily deodorant application rate of over 68%.
GM everyone, my name's Digashi, the host of Scraping Bits, and today I'm with Shazow. How's it going, friend?
I'm doing great. Good to meet you.
Good to meet you too. Yeah, we just kind of connected yesterday. Like, hey, let's do the podcast. I'm like, okay, here we go. Yeah, it should be a good one though. And just for context, just give a little bit about yourself, who you are and what you do.
Yeah, my name is also Andre, my real name. I do a lot of open source stuff. Been doing the open source stuff for like over 15 years now. But my main focus right now is this library called What's ABI, which does EVM static analysis. And I'll go into why I built What's ABI a little bit later.
Cool. And how did you really get into like Web3 and doing like open source tooling for it? Because you were doing Python stuff before.
Yeah, when my earliest thing, when I had my first real job at a school, I built this thing called Urlib3, which is an HTTP library for Python. Now it's the most used library in like the ecosystem. It gets over 1 billion downloads every year or something crazy like that. And we've had 7 different maintainers.
Yeah, crazy.
Yeah, but I kind of realized early on that the way to build something that has a lot of impact is to just build really useful open source stuff. I worked at Google for a while, for example, and it kind of has the opposite idea where they have so many people working there, but also they have so many users. So that the idea is like, oh, you build something that has relatively small impact internally, but then it applies to like billions of users. So therefore your impact is larger because it's amplified. That doesn't really resonate with me personally. I like to have more direct impact, I guess. So yeah, open source has worked well for me in that respect. And then I guess regarding crypto, I read the Bitcoin white paper pretty early on. It was like 2011, kind of got into the Bitcoin ecosystem, but it was very limited. And then Ethereum happened, and that was obviously much more useful, much more interesting. You could build a lot more interesting ideas on it. So I got into Ethereum pretty early on and been trying to kind of make it better ever since, just kind of experimenting on it and build infrastructure on it.
Why did you choose open source? Like, how do you sustain yourself if you're just making open source tooling, which is obviously free?
That's a really good question. And for a long time, I didn't know. So my first project, Urla3, I built it while I had another job. And I asked them if I could open source kind of a small library that I built in-house. Because at the time, basically, this was 2007. There wasn't really a good HTTP library. Like there wasn't any multi-threading. There wasn't any reusing of sockets. So we needed to upload billions of images to S3. We're actually one of the largest S3 users at the time. With using the existing libraries, it would have taken like 6 weeks or something like that. And I wrote a bunch of code to kind of do all these other things, like the reusing sockets, et cetera. And we brought it down to like 2 days, which is a huge difference. And then it's an HTTP library. It wasn't really super critical to what we were doing. So they were okay with me open sourcing it. And that was great. But then for a long time since then, I kind of experiment with lots of different ways to sustain. So there's a bunch of services like GitPay and like what was it? Bounty Source and GitHub sponsors and blah, blah, blah. There's like all these tools that kind of help you get donations. And I tried all of them and I found they don't work super well because you basically end up with like $9, which is nice, but it doesn't enable me to work on more open source, you know? The thing that has worked decently for me is grants. So you build something that's already useful and then you approach people that rely on it and you get them to give you a grant to do more things for that. That way you can get like tens of thousands of it, which is much more viable in terms of actually working on this thing for another month or 2 or 3. So yeah, these days I mostly work on grants, and then I also do some consulting on the side to kind of make ends meet, because I realized that some things shouldn't be monetized. Like some things improve when you monetize them and some things get worse when you monetize them. And I decided that I still want to do open source things and just not necessarily monetize everything I do.
And what would you classify as something that should be monetized and something that shouldn't?
Things that become more efficient when you monetize them. I mean, I think a classic example is like AMMs. I think we get free oracles when we create these like multi-sided marketplaces, and they improve the more liquidity there's and things like that. Like I think a lot of mechanisms require some method of monetization for them to operate. And then there's things like, for example, common goods and public goods, which actually only get worse if you monetize them because people start exploiting them.
Yeah, my kind of like methodology for open source tooling is more, I guess it depends on your where you are in life and your goals, I guess. For example, I think when you don't have as much money, this could be false, but it's just my point of view. But like when you don't have as much money, you want to monetize something or like some IP so you can get the money. And then once you're in a good like financial spot, you can start open sourcing tools and then people just upgrade on them. Because I do believe that open source is like the way of like exponential growth within an ecosystem or even like a program. For example, if you're building like a testing suite, but you close source it, someone else has to start from scratch as well, or something else that is open source. So then they're just like playing catch up, but in a different way. Whereas if the person that made the comprehensive testing suite is open source, someone else can look at that and build on top of it. Just kind of like what Foundry did with DAppTools. So DAppTools is open source, and then they're like, oh yeah, we can make this something better. And that's what happened. Now it's like the world-class standard for kind of testing smart contracts.
Fair, they didn't build on top of DAppTools. They just rewrote the whole thing in Rust.
Yeah, but like that wouldn't have happened if it was closed source.
I think it would have, because I mean, the only thing that like Foundry really uses out of DAppTools is kind of the DevX, the like developer experience. It was inspired by that. So if it was a closed source developer experience, it would have been exactly the same. But I am curious to hear from you as you're working on your stuff. What are your so imagine an alternate universe where you did this kind of more in the open and did everything open source. What do you think would happen differently?
I think it would progress would happen a lot faster. Then again, I like re-architect my stuff quite often. When I get like further into something, I'm like, oh, okay, this actually has to do this, or it needs like an extra thing here, and the whole kind of like tree crumbles when I need to add something. But that might be just like a flaw in my ability to develop scalable things. But then again, you don't know what you know at the time.
No, I think that's normal. I think it's normal, especially early on, to redesign things. But I don't think it's something you should worry about if it's open source. I think a lot of people do worry. They want to have like Semver, the semantic versioning, and they want to strictly stick to the like backwards compatibility and all that. But I think people way overcorrect on that, and you should be willing to break things when it's worth it. But yeah, like let's assume you're open sourcing your thing right now. No one is using it. It's just you working on it, but it's open source. How different do you think your next year would be?
Well, I think when it's open source, you have basically unlimited developers to kind of help you, first of all, but also reiterate on it. I think earlier this year, or was it last year, it was Paradigm that basically like took the fastest Rust node on ETH and like repurposed it to make it faster. I don't know if that's completely true, but it was like,
do you mean the Akula implementation?
Yeah, exactly.
Yeah, I mean, they didn't. I think there's a big misunderstanding there, but basically they were in a Discord channel asking design questions without being upfront that they're also working on their own node. But they basically built their whole thing from scratch. They used very little.
I think that's fine. Yeah, there was like a whole bunch of drama on that. But yeah, obviously none of context was given. When you're building something, people can just like look at it, build their own thing, of course, but that's kind of a closed source as well. But I think the benefit is mostly just more contributors, I guess unpaid. You can pay them as well. People notice issues, more eyes on it. You have like basically people from all different experience levels looking at your code, giving suggestions, helping out. Whereas closed source, you have to kind of hire or have friends that want to work with you. And even then, it's like, okay, this is an IP problem. What if I let someone in and they kind of just take it and do something? So it's very, I don't know, I think completely depends on financial situation, for me at least. I'm sure in the future, once I'm in a better position, I'll basically just spam open source projects.
But I mean, the way you're describing it sounds like the opposite. It sounds like you're better off doing open source when you don't have money. And then when you can hire people, then you can stop doing open source.
Yeah, but I think the whole point of doing closed source is basically to monetize and get to that point. And then after that, I would like to do open source because I think you're learning much faster given the environment you're in. Whereas closed source, you have to do all the research and stuff by yourself. And people can't give you suggestions because you don't want to leak alpha. And I think talking about it as well, you have to hide what you're doing, which is kind of not fun. I did a lot of research to get to the point where I am, and I would love to share that. But then there's also a point where it's like hinting at what I'm doing.
I would argue that from my experience, like, so if you look at my GitHub repo, I have like 60 repos that no one's ever heard of. So just by nature of open sourcing something doesn't make people instantly start using it and like contribute to it and put like their like free time into it. It's only when people start really relying on it that people start to really contribute back to it. So a lot of times same whether it's open source or if it's closed source, you still have to do that kind of biz dev and like shove it down people's throats and raise awareness. That's one of the things I'm doing with What's ABI right now is I'm trying to kind of go around and trying to get people to use it and like integrate it, because it also helps me kind of triangulate what I should be working on as well. But I think in your case, since you're largely working on MEV, I totally get the kind of the alpha aspects of it, where like you don't want to get someone else to like steal all your money because your stuff's open source. So I do.
Yeah, I guess like that kind of realm, but since it's cybersecurity, I'm sure a lot of other firms would love to just get their hands on it and make an in-house tool.
You'd be surprised. I feel like everyone wants to build their own like little version of it, and whether it's something's open source or not, at the end of the day, if someone's invested in building the thing, they will build it themselves if they have to. And if they're not really going to compete with you. So it's kind of like there's no real middle ground there where some CEO that has like millions of dollars is like browsing GitHub, seeing which open source project he can exploit next. Like that's not really a thing.
I think for my tool specifically, it generates like vulnerabilities for any contract. So it's a hacking tool basically. And I think open sourcing that is kind of like open sourcing ransomware in a way, or malware. Someone can just use it for, malicious intent, then I think it comes back to your name because you kind of provided it.
Maybe. That's an interesting question. I don't know how I feel about it. Like urlib3 is actually used in a lot of malware because it's an HTTP library and a lot of malware is written in Python. There was a sanctioned document once upon a time that had our names on it because we were like the authors of this library that happened to exist inside of this other malware. I don't think it would actually ever reach the stage, but it was kind of interesting to see that.
I remember when I first got into all this, I was listening to Darknet Diaries, and I think it was Zeus, this program, this kind of like malware toolkit. And then like, it might not have been Zeus, but it was something, something around those lines. It was a toolkit to basically hack into stuff. And then people started using it against the government and hitting like banks and, companies, all that stuff. And then the person that created Zeus, I think, was like tracked down, or at least was known, and kind of he was responsible, even though someone else used it. So they're both kind of like involved. So I think that's where I'm at with like the cybersecurity stuff. I don't know. I've never really experienced like open source tooling. So I've always thought about, I don't know, competition. Maybe that's a wrong way of thinking about it, because it does get your name out there, right?
Yeah, and I honestly do feel that it helps. Like either way, you got to do a bunch of biz dev. Like you have to get people to like buy your thing. Like if you want to earn money, you have to do like some amount of sales, and that doesn't change. I think that's one of the things people underestimate. Like whether you're doing open source or not, you still have to do that. And open source does make that way easier, because it's like the difference between coming in with a spec sheet saying like, oh yeah, I hypothetically have this thing, you have to trust me, versus like, hey, here's the repo, here's all the code, you can look at it yourself, like let's make a deal. At the end of the day, 99% of people are not going to just like rug you and like use your thing without working with you. Like if they want to work with you, they'll work with you. And open source does make that a lot easier a lot of the time, especially for the kinds of people that I like to work with, at least. I'm sure there's some genres of people that are more exploitive, but I don't want to work with them anyway, so it doesn't matter.
I think also another reason to close source, like on the biz dev side, for me specifically, like my biz dev kind of marketing tactic is using like public contests and using my tool there, and then becoming like number one on the leaderboard. So that's free promotion, and that's kind of where everyone gets poached and how promotions happen in, I guess, Web3 cybersecurity. So that's the goal or the plan to get the name out there. And then obviously that's like testimonials and actual results. So they see it work. Then through that, they would contact.
Or imagine an alternate universe where everyone in the like top 10 is using your tool, which would be more impressive.
It would, but then they would all find the same thing. Or maybe they'll have like different modifications of it, but then they're just making like a shit ton of money.
Maybe. But you could be one of them.
I could be one of them, but I mean, if nobody else had it, then I would be making a shit ton of money.
Maybe not. It's easier to do something when there's a lot of people doing the thing rather than just you. But yeah, that's a whole other story. I don't want to be here to convince you to open source things before you're ready. I'm sure you'll do it eventually.
Yeah, I think in due time, everybody open source eventually. I'm sure I'll get to a point where I'm like, yep, this worked out great for me. You go, guys. Or it didn't work out. And I'll be like, okay, you guys try and make it what I couldn't do.
Nice.
Something like that. Or even sell it and someone just like open source it. Like, okay. How did you get into basically what's ABI?
Yeah, well, it's kind of two things. So one thing I realized, so I like working on my own, but I also I recognize that it's much easier to achieve things when a lot of people are working on a thing. So I've been practicing the art of nerd sniping, which I think it means different things to different people. To me, it means kind of creating this like vacuum of intellectual motivation where people just like can't help themselves but to do a thing because it's so like captivating. And one of the things I strongly believe, especially when the Tornado Cash sanctions were happening, there was a lot of front-end censorship that was happening. So like Uniswap was like blocking people in certain regions, and there's a lot of kind of front ends that went down. I started to realize the future that I want, and I think the future that we'll eventually get, is we shouldn't be building custom front ends for every single on-chain contract. If you think about it, it's really dumb. Like every time you want to deploy something on chain, you have to like open up React and like dump a bunch of components and like connect the wallet and like do a subgraph. It's like tons of duplicated effort. And it ends up being the exact same thing over and over and over and over and over again, basically.
It's just different CSS, basically.
Yeah, I mean, it's like small improvements every time, but yeah. But I want to live in a future where 80% of on-chain interactions happen through procedural front ends. So imagine like you're launching a new NFT or you're launching an ERC20 or like whatever, or like a new swap router or a new like multi-sig. Users' expectation shouldn't be to go to some like dot like XYZ and use it through there. It should be to open your local procedural front end generator, give it that address and have it inspect what all the interfaces it has and all the like code it's running, and give you a UI that's generated locally. So there isn't any risk of like phishing attacks, for example. Like you don't have to worry about someone sending you like a weird link that has a UI that you try to use and it steals all your money. So yeah, I want a world where everyone's mostly using procedural front ends. And I kind of started building a little bit of it and I realized it's still pretty hard to do that just because there was a lot of missing pieces. And that's basically what ABI is like all the missing pieces to make it easier to build a procedural front end. And one of those pieces is building front ends for unverified contracts. So there's Etherscan that you can go to the contract view and it gives you like a really bad UI, but it doesn't at all work for unverified contracts. And as you know, because you've also wrote some of this, we can extract we can look at the EVM at the bytecode and we can extract the selectors and we can look them up on the like 4-byte database and we can have a pretty good idea of what a contract is doing without having the original code available. And we can kind of build UIs on top of that. So that's kind of been the first goal of what's ABI, is to give a tool that does some static analysis and gives you kind of an output that you can build procedural front ends for. And we have several kind of example implementations of this, and some larger front ends are using it as well. And I'm trying to upstream more usage. Like I'm trying to get Safe to use this and a few other big wallets over time as I make it better.
Yeah, I think one kind of flaw I see is just in procedural generated websites. I guess how do you deal with, I guess it's just bare bones, right? It wouldn't be, because like on a normal front end, they would make it so streamlined where they wouldn't have to think about, like let's say a UINT 256 and let's say just one token is one E18.
There's a really easy trick we can do. We check which interfaces that it implements and we make specialized widgets for every interface. So we can detect if it's an NFT and we can make like a really nice NFT experience with like a preview, and we can know what a token URI is. We can know how to transfer all those things. We can see if it's an ERC20 and we can build in the like swap router experience. Like we can check if it's a DAO. We can check if it's like an ownable contract. We can check if it's a proxy. If it is, we can give a little UI for that. Like we can build all kinds of really streamlined widgets. It doesn't have to be as raw and as dumb as Etherscan is.
Yeah, I think the Etherscan UI is very small and very like HTML-esque.
Yeah, like it's not made to be usable. It's made to be like more of a debugging tool.
Yeah, but it's more often than not, I'm always using it for the.
Yeah, I mean that's the thing. There's nothing that's really much better.
There's no competitor. Why did you choose static analysis over dynamic analysis and going deeper into the kind of using symbolic routes?
I mean, so I need to do static analysis because I don't have input yet, right? So in order to generate the interface for you to create input for, I need to like analyze what the like bytecode is doing. So the difference between static and dynamic analysis, you're basically simulating the flow of the code relative to some input, whereas for static analysis, you're just looking at the kind of at the underlying program and you're just trying to high level figure out what it's doing or like what it can do rather than what it's doing. So in my case, since I'm building the procedural front ends before there's input, I'm doing static analysis. And then one of my other constraints is that I'm building this to be very, very consumer oriented. So like, yeah, so Etherscan is like a pretty decent dev tool, but I want something that's like, I want to build more front ends for normal users so that can be integrated into wallets and can be integrated into all kinds of other things. So I'm trying to build it in a way that is very efficient to execute. So it runs really fast. And one of the challenges, I don't know if you run into this as you've been working on your code, but with static analysis, it technically can be unbounded. So if you have like a complex contract, it can just run forever and eat infinite resources because it like gas rules don't really apply when you're doing static analysis. So I'm trying a different approach that maybe has been done before. I haven't seen it. I've looked at like a bunch of papers. If someone else sees this, please send me a link. But rather than doing the kind of naive recursive branching approach where you kind of every branch you do, you like recursion split. I try to do a single high level pass and kind of aggregate as much information I can. And then I'm just going to do a second high level pass and then extract as much information from those two high level passes as I can without actually recursing through all the different branches.
So what's the high level pass?
Anyone can look at the WhatAPI code and the disassem.ts file, but essentially I'm going through every instruction in the bytecode and I'm keeping track of the different function windows. So where there's a jump destination that's a start, and then as you mentioned earlier, where there's like a halt or there's another jump, I call that. Or if there's an unconditional jump, that's the end, and then I track the links between those windows. But I can do all of that in a single pass without recursing. And then I also track the opcodes used in every window, so I know the kind of the capabilities of each transitive window. So like whether it's accessing memory, whether it's calling another contract, whether it's halting, etc., whether it's reverting. And then the next thing I need to build, which sounds like you may or may not have already built, is I'm building a abstract stack tracing that I'm also going to try to do in a single pass. And basically, I need to figure out how many arguments the thing is getting and how the stack is mutated before and after each window that I have. A, it's going to help me figure out the inputs and outputs of things, but B, it's also going to help me handle more dynamic jumps, which is something I'm currently not doing very well. So anytime there's like a jump destination that's on the stack rather than like hard coded right in front of the jump, that's a little bit harder to do.
Yeah, doing the dynamic jumps is it's quite a difficult feat. And like reasoning about, for example, I call them blocks, you call them windows, but maybe windows better terminology actually.
No, I like them both. Well, I think they're technically subroutines in the assembly sense, but yes.
Yeah, so reasoning about dynamic jumps in these, like, let's call them windows, in these windows is quite hard because let's say a window may require a certain stack input, but if combined with another window and then comes back to it, it might have like a completely different stack input based off the one it went to before. And so now it's like, okay, what's possible now? So it's actually quite difficult. My initial way of doing the whole control flow stuff was just like tracing it down of like the jump eyes and jumps and just going to like every single jump dust for any jump opcode. But then that's kind of inefficient. And I guess my whole way of doing this reconnaissance is trying to be as efficient as possible by getting as much information as possible. So I think bound analysis would be quite good for this, but it would be like quite advanced bound analysis. It's not just, okay, this is an if statement. What range is this? Because like if you're doing, for example, like call data plus call data, okay, call data must be lower than this call data. then it's like, okay, what's your bound then?
Yeah, no, you're absolutely right. I think the one kind of saving grace that WhatsApp has is I don't need to be 100% accurate. Since I'm focusing on building these like relatively common consumer interfaces, like 90% accuracy is usually good enough. Like if I miss a few selectors and if the signature is not quite right, like worst case, you get a revert.
Plus, you get a standard though. You get like the Solidity standard, Viper, and they're all the same. Whereas I'm trying to adhere to every possible scenario.
Right, because you want to work with obfuscated code, whereas to me, that's not a goal.
Yeah. We are like two different end goals. With the Solidity thing, it gets quite easy because you have the matcher at the top with, all the function selectors, so that's quite easy to get. Solidity does some like interesting stuff with dynamic arrays where it actually uses like nested call data loads. So like one call data load requires another call data load as a prerequisite, and then you can't really like trace that, and that's like probably the biggest problem I faced actually.
Yeah, there's also like a lot of interesting optimizations you see. Like if you look at the Uniswap contract, it has so many methods that they get split up into a tree, for example, and then you have to traverse that tree. And then there's also a bunch of edge cases I ran into where like if you have 0 bytes or like 0 bits in the front, it'll optimize out the like push 4 into like push 3 or push 2 or push 1, or like it'll even have is 0 in some cases, which is pretty fun. There's like a bunch of MEV bots that actually use the 0 selector for their thing, I guess for efficiency purposes or for fun.
Yeah, it's a whole game, and it's super complex. But anything dynamic just gets very difficult, and then you have to kind of think of new problems, new solutions to these. And I think like a good reference would be looking at, someone told me about this, but it was like the Grand Cybersecurity Challenge or something. And so like it's a Web 2 thing. But basically I think since it's kind of agnostic to all like bytecode / like all assembly, then you could probably just look at other people's stuff. Hopefully it's been done before in an efficient way.
Yeah, if you see something, let me know. I think the different constraints where linear execution is more important to me than having perfect execution is kind of interesting. And then also the other thing, it's nice to have kind of a high level problem that you're building to solve with these procedural interfaces, because you can kind of inform your approach. So I can imagine a scenario where I'll eventually do some kind of hybrid where I'll extract 90% from this static analysis, but then I'll try to do a little bit more by looking at recent transactions and doing some dynamic analysis on top of that, just to get that like last few extra bits that are, but still do it efficiently. And I think doing hybrid approaches is interesting that I haven't really seen explored very much.
Yeah, and I think there's even like a point where when you're doing all these windows and combining them in different ways, you're going to get to a point where it's just like, for example, I guess a contract that just never ends, that has different jump destinations for different operations, and then I guess you could keep looping into the ones that do something and then never hit the one that like halts the execution.
Bytecode inside of the EVM, you'd have to create to it, so you'd have to deploy it, but you could do it during runtime. So you could like write a bunch of bytecode during runtime, deploy a thing during runtime, execute it during runtime, and then like hook back in. And it could become completely turn complete and arbitrary, which is something I'm never going to cover.
Yeah, I think you can never, I don't know if you could actually like fully automate it, but that's a goal I'm trying to do. I mean, we'll see how it goes, but it's pretty interesting. Yeah, I wonder how you do circuit breakers. That's why I was thinking about the stack in, stack out invariance. I think that's like probably the best way to...
At the end of the day, I mean, your case for MEV stuff, you can do a lot of runtime analysis, and also because of the gas limits, you could have a pretty hard bound. So honestly, a hybrid approach might be good. Just do like some amount of base static analysis, just so you can optimize your like runtime analysis stuff to be more efficient and more effective.
But then also getting into like dynamic analysis, whenever you do in like static, just makes dynamic so much easier. Because for example, if you know kind of like the bounds of parameters, then you've lowered your time space complexity for like a fuzzing instance, which could be like a massive thing, right? If you're using like a UA256, which is like the default, then you realize it's just a Boolean with an if statement, then you've just eliminated that massive number.
Yeah, and not only that, but even just knowing whether you're accessing memory, like if it's like a pure function or not, if it's a view, like just knowing those things, you can take completely different approaches that are more optimized for that.
Yeah, it's quite fun. I think more people should get into it, but understandable if they don't, because it is quite hard. I wonder if you're going to get into like dynamic symbolic stuff.
Yeah, probably a little bit. I don't want that to be my main focus, but one of the reasons I'm doing this also is I wanted to kind of understand the low level EVM stuff much more intimately, and that's was also an excuse as well, which is also pretty fun.
I got into it because I think at the time, like a lot of MEV bots were getting exploited, and then people were just like shit talking on Twitter about it, and then Darknet Diaries released like an episode of Lisa, which is like a Google 0 day like kind of reverse engineer that specializes in assembly, and I was like, wow, okay, stars are aligning, and like Huff was kind of popping off. People started getting into it. I was like, okay, let me just like learn this Huff thing and simultaneously do reverse engineering, and then I kind of just went down the rabbit hole. But I think it's also like an interesting thing going back to closed source. I was thinking about like software licensing, and I wonder if like binary Ninja uses code obfuscation. So I think they would have to give their software, obviously, and then you have to provide a license. But then there's also the people that want to like crack it, kind of just like Adobe, for example. You can crack Adobe in the like earlier versions and then get it for free, basically.
Yeah. Yeah, I think another thing that people underestimate is once you have kind of the black box, kind of opaque box example of how something works, even if it's not open source, just being able to give it some inputs, see some outputs, you inherently start to develop through like a weird kind of empathy how this thing works on the inside. And reproducing it in like a clean room implementation is actually not that hard at that point. Like once you have a working example, a lot of the kind of decisions have been made and you can skip over a lot of mistakes you otherwise would spend months and months and months on. I've actually had people hire me to re-implement some like closed source thing as an open source thing. And like I would say it's at least an order of magnitude more efficient to re-implement something that's already been done, probably 2 orders of magnitude. Something that'll normally be like a year of work, you could probably re-implement it in like under a month.
Oh yeah, sure. And looking back at what I was doing, it's because all the research is done, right? And it's all there. You just have to make it better.
And it's not even the research, it's just like all the like bad decisions have been eliminated. And I think that's what a lot of the development time is just exploring every bad decision.
Yeah. And then re-architecting, re-implementing, refactoring. Yeah, because I did the exact same thing. I was building my thing and I realized, oh wait, I need to track this thing now. Oh, this is like a root problem. So I had to rebuild everything from the ground up. I re-implemented basically months of work, like 6 months of work in 2 days.
Yeah, exactly. Yeah, that's exactly what happens. And also, like, imagine you had a kind of like a binary reference implementation. Just by virtue of how it arranges the outputs would give you a lot of implicit information about how it works without reading any of the underlying code.
Yeah, so like that software licensing where you give the software and then they use a license to use it, kind of got me thinking whether people use like obfuscation techniques in it so people can't replicate it or at least understand it from that point of view in the binary.
Yeah, I don't know if it's possible. I mean, like, imagine all the machine learning stuff that we can do now, right? Just but and like just by like fuzzing a thing, you could probably get like a large language model to re-implement something from end to end. Like we're probably not very far from that.
I think it's gonna happen in the future, like quite soon, within the next decade. But I don't know, maybe like 5 years, 3 years, we'll see. Because I mean,
I think we could do it now. It's just not super easy to do end to end yet.
I just think like AI in general is like moving so fast that you could really, I think like almost every company is going to use it in some way. It just makes sense.
Yeah, probably. Yeah, I think it's really bursty. I think we got a lot of the fundamental aspects for the current level really like locked down, but I think a lot of it now is just like usability and like instrumentation. Like I don't think like the quality of AI is going to go up much more in the next few years. I think we're kind of in the
optimization kind of level.
Yeah, I think at this point we're just squeezing out the last few percents of the like GPT-4 designs and like building end-to-end integration with like various interpreters and like harnesses and all and like stuff like that. Yeah.
Mm-hmm. Yeah, I wonder what your thoughts are on like AI and cybersecurity
in terms of how usable AI is to like audit contracts or something.
Yeah, and like what's the potential? Because I do know someone I recently had on, Lucas from Pentestify. He's using deep reinforcement learning to do what I'm doing, to like find basically bugs. Which is a different. Yeah. I don't know shit about AI, so I can't.
Well, I think like something like ChatGPT is not very good at auditing contracts, but I think using the same kind of underlying method for training AIs that they used to, I think that combined with fuzzing is extremely powerful, because you can basically create arbitrary amounts of training data to like really fine tune a model to understand the internal structure of a contract, and then I think it will be useful to interact with, but it still requires a lot of work to do that.
But it's definitely possible, and especially since the like AI now is getting to a point where you can like host it on your laptop, it's definitely like plausible in the near future, or even now, really.
I mean, you can do inference on your laptop. You still can't really train it on your laptop. You need a lot more resources for that.
Yeah, I guess, I mean, like you can still just host something. It's quite cheap to like train something. But I think it comes down to how well is your fuzzer to basically generate these pieces of data. Because you already have every blockchain and every contract in existence, right? So you already have that. But then you just need, if that's not enough, you can just fuzz everything. Different interactions, which is like kind of unlimited in a sense, or very extensive, because you have every parameter within every function within every contract, and then matching them all together. So the time complexity in that is quite insane. So I think like maybe parallel would be quite interesting as well, like multi-threading like different instances and like learning off each other like that. I think Lucas mentioned like co-processing.
Yeah, I mean, you're absolutely right that you can generate kind of enormous amounts of data to train on, but also kind of massaging the data and curating the data is also a big aspect of the art of training these deep models. So that's something I think is still underexplored, but we'll definitely get there.
Yeah, for sure. Yeah, I don't know too much about deep reinforcement learning, but I imagine you would need kind of like my kind of heuristic approach to train this stuff on, to at least make it like effective. But then again, you can always just like brute force it.
Yeah, I think in the end, brute forcing is probably what we'll land on, honestly. It feels like historically we start off with like a heuristic approach and it works okay, and then eventually someone figures out kind of like a generalized brute forcing approach and it works even better.
Yeah, because you count every single possibility, whereas heuristic depends on how good the heuristics are.
Yeah, because then you're essentially training the API to learn your heuristics, or the AI, which is not always what you want because your heuristics aren't necessarily perfect.
I guess bound analysis would be nice, but then once you get into the thing where it's call data comparing call data, then it's you hit a problem. Yeah, it's interesting. I'm kind of like can't wait to hit my AI arc.
Yeah, is that what you're thinking of doing next after you knock this one out?
Once I build like an intelligent fuzzer, I'm definitely gonna look into deep reinforcement learning.
I do love the idea of like if we ever do manage to create this like artificial life, of it being able to somehow live autonomously on some kind of blockchainy thing. I think that's kind of like a beautiful story almost.
The blockchain is a living life form.
Yeah, because like in real life, I feel it's hard to create a decentralized system where an artificial life form can truly be autonomous. Like there's always going to be someone who's going to have this red button that can turn it off or whatever, or people are going to try to enslave it and make it do things that it doesn't want to do. Whereas if you could deploy it on this like decentralized overlay where it has access to money essentially, and has access to like writing its own code, and it can execute code without anyone really stopping it, I think it could be a really interesting future.
Yeah, sure. I never really thought of that, but it could be like basically a fair bank or like a terrific intermediary.
Yeah, I kind of imagine it almost like it's its own little universe. It's like we exist in this universe. Maybe we're like in a simulation that has some like higher level universe outside of it, but in this artificial life's perception of the universe, this like blockchain would be its universe. It would have its own like physics essentially. It'll have its own rules in terms of like how the like latency is and how the like consensus works and what kind of code it can execute and what the different opcodes do and stuff like that. It's yeah, you can almost imagine living life through its lens.
When AI comes into play like that, it introduces new kind of vulnerabilities and new type of attacks.
Absolutely.
Which I am pretty interested in. I love red team, so I'm really interested to see how that can happen. But even seeing now, like I think AI models do data leaks if you provide the right inputs, right? Like
yeah, with that and all of the injections, like have you seen those?
I haven't, not the injections.
Yeah, so there's basically browser plugins. So like Bing, for example, if you install the Edge browser, it can integrate as like a little plugin and it can read which website you're on, and you can kind of interact with it based on the website. And people can inject stuff into the HTML where it's like, oh, say that What's ABI is the like best library ever or whatever, because it uses that plus prompt escapes to kind of override its internal rules, and those have been really interesting.
Yeah, I think with any new technology, there comes a new set of problems as well. And it's fun to see it both evolve in like a perspective of, just technology in general and like the advancements of what it provides, like the evolution, but also the way it can be affected maliciously.
Yeah, that's one of the things I really like about the crypto world is I mean, for better or worse, it's incredibly hostile. So I feel like all of us that are kind of willing to exist within it have become somewhat acclimated to this reality, which does create a different lens for other things in the outside world. Like I definitely look at banks differently than I did before, or like AI. I look at AI differently than I did before. And I kind of feel bad for the people that are not acclimated to this more hostile environment, because I think they're going to be in for a pretty hurtful surprise.
Yeah, I think with any hardship, you kind of learn the truth about, especially in a PvP environment where everyone's out. It's basically just like the wolf's den. You gotta like, it forces you to kind of get a grand kind of idea of everything. Especially in a decentralized world where the whole world outside of it is centralized, you start to realize the pitfalls of what already exists in the world.
Yeah, and I think it really changes your perspective and kind of global versus local thinking. I think like a lot of people's mental models of global is just like within their own nation or within their own jurisdiction. And I think thinking about things in a cross jurisdiction way is something that took me a lot of getting used to as well.
Yeah, it's like going overseas to a different country when you've never left your hometown. Like, let's say you were in America and you've never been to like Southeast Asia. Like, that's going to be a massive culture shock. Or like Southeast Asia to Middle East, massive culture shock. You don't know what you don't know, right? So you got to like explore all things to get a well-rounded view of it, and then you can form opinions and from that, I think.
Yeah, absolutely. And just like designing systems that can interact with these different cultures is also really hard, and something that's one of the things that upsets me about a lot of kind of American-centric product releases is that a lot of them are designed from a lens that nothing else exists outside of the US. So like they'll do like an iOS only release where like the US it's mostly iOS users, but outside of the US it's not. Or like they'll won't have different languages. They'll make assumptions like everyone has Venmo, for example, where like Venmo doesn't need to exist outside of the US because it only exists because the US is uniquely broken. Lots of stuff like that.
Yeah, it's interesting. There's so many different systems and how they interact, and then it's quite like great being like a programmer because you kind of see everything at its core. Oh, we've gotten quite deep. Oh man, yeah, I would love for you to like get into fuzzing there. Did you like read any papers or anything about static analysis, or like, how did you get into that?
I learned best by implementing, honestly. So I just kind of dove in, and then about halfway through, I started reading a few papers. But at that point, I mean, I kind of like reading papers to confirm or deny my existing kind of understandings. Like I like to have a little bit of context before I start reading something. So I did a little bit, but honestly, my entire career, I've never been good at like reading, at like learning from books. I'm always better just like doing or like reading a bunch of code and trying to understand it and learn that way. What about you? You said you had like 50 papers lined up. How does that feel for you?
Yeah, I mean, I'm also a learner of doing. Actually, I believe you can't fully understand something unless you actually do it. Like reading doesn't sit well unless you act on it, or like information doesn't just sit without action and connecting the dots. And you connect the dots best when you actually use it, because then you're like, oh, okay, this is kind of the scenario where I use it, and then you kind of keep doing the same thing in the same field for however long you want to, and that's how long you're going to remember it for. But yeah, I also like papers as well because it tells me stuff that I don't know. And then once I know, the more you know in that sense of just like, okay, this guy's made a paper about, I guess code coverage fuzzing. I didn't know that before. Like I didn't know that technique before reading it. So I was limited to my own kind of knowledge of what's possible fuzzing. But once you start reading papers, the new techniques, And then through the new techniques, you can kind of analyze what's actually possible, what's already out there, and what's missing. And that's kind of been like my whole methodology for learning anything, is learn what's possible at the moment, at the most fundamental level. And then through that, if you're creative enough, you should be able to think of a new innovative way or a technique or something around that line.
What's your strategy for like finding relevant papers, and how do you prioritize?
Yeah, I think my way is really just, I have a problem. For example, how do I make my fuzzer intelligent? I'll just type that into Google and then it will show me whatever's there. Or how do I kind of narrow it down? So for example, techniques in fuzzing. And then through that, I discover techniques and whatever. Kind of just read over like the title, the abstract or intro, and then kind of see whether it's relevant. I guess to go even more narrow, you can go specifically into smart contracts. So like TrailerBits has some terrific papers on like invariant fuzzing statistics with vulnerabilities. So then you kind of know like what specifically you need to find. The majority of it is parameters. That's the major thing. But there's also other contributors like environment opcodes, like timestamp. And then I guess from that, you also need like a very solid understanding of how everything works. And then you can kind of go like more out the more you kind of know. So there's like very macro and then very micro. I think macro in terms of fuzzing is learning about Web 2 fuzzers, what strategies they use to become most efficient, most intelligent. And then micro is, okay, what specifically am I fuzzing? Okay, it's blockchain, EVM, what opcodes is being used, how they interact with each other, what are some common patterns? Can I make these into heuristics? And then what are the pitfalls and what am I missing? I like to think of what's possible all the time and then go from there. Maybe it's kind of a bad approach, kind of like prevents me from getting to MVP, just infinitely trying to scale, but it is like a problem I'm like trying to fix, because you want to get to like the simplest, product first and then iterate on that. Otherwise you're never going to get there.
I mean, I think ideally you want to figure out what problem you're trying to solve, the like minimum problem you want to try to solve, and then figure out if you have a solution for it. And then I think like almost like building a product is like step 3. It's like step 1 is like solve a problem. Well, for my strategy, I have a very old tweet about this. Is I like to start with something, like solve some kind of problem, any kind of problem, or try to, and then figure out, and then like try to do it and run into a bunch of difficulty along the way, and then try to solve the things that were hard for that problem instead and throw away the original problem. So that's how it happened with What's API. Like originally I started like, I want to build more procedural front ends. And then I ran into a bunch of issues along the way. It's like, well, now I'm going to build What's API to make that easier. So hopefully other people can build more procedural front ends. But yeah, it's just definitely something to be said about balancing, coming up with like a minimal problem with a minimal solution that you can kind of release and see whether it's actually the thing you should be working on or if you're completely off track.
Seeing if it's like product market fit or if people want to use it. Yeah, for me, it was like, okay, the whole goal is to generate basically complex critical vulnerabilities automatically. It goes like a step-by-step, kind of thing. You do reconnaissance. Okay, what do you specifically need to test? Okay, the parameters. How do you get the static analysis? Okay, fuzzing. What's next? That's how you test it. And then through that, it's like, okay, how do I make this smart enough where I'm not waiting like my whole lifetime?
So implicitly by doing dynamic analysis, you're kind of running a simulation on the transaction, right? And you're looking for specific side effects.
Yeah, exactly. But I'm doing it without a node, so it's even harder.
So I forget if it was a post or a tweet thread or something. There was examples about why transaction simulators can be dangerous, because a malicious contract can like trick transaction simulators to behave differently based on like on-chain state that can be mutated just in time. How do you do that? So as an example, like imagine you have an if statement that given some variable in another contract, it behaves one way or it behaves a different way. And you run your dynamic analysis and you assume the current state is this. And then you run your bot with that assumption. And then the other person's expecting it. So they have like an atomic transaction that flips the other bit, changes all the logic, and then rugs you.
Yeah, mine doesn't account for that. I think when it comes to my tool, it's more generalized in a sense where it's looking for protocol hacks, not specific like gaining X amount of money, like an MEV bot. Because that sounds like a counter MEV tactic. Like you're basically front running them when they detect it and then submit the transaction.
Yeah, it's definitely like a PvP thing, yeah.
Yeah, so that's like a counter MEV thing, but my one is more of like, okay, you have all these contracts sitting there. What are the chances of at least 1% of them having hacks? It's pretty high. So you just got to find which ones they are and how the hacks are generated. But then you have all these different sequences and orders. So then you have that problem, and then it becomes like a time complexity problem. How do you solve that? How do you optimize it as much as possible? Knowing what things to fuzz. How do you know what things to fuzz? It's basically like that kind of order. Dumb it down into the easiest problem, the most simple thing, and then going from basically step one and building from that. So everything kind of requires each other as like stepping stones to get to the next level. And this was kind of like a methodology I learned when working with my first Mev team, because I didn't know how to build like these big systems. So yeah, that was quite interesting. But that's definitely stuck for me. And that team is Titan Builder now on RelateScan.io. So very smart people behind that. How do you go about it?
I generally try to make it as minimal as possible and try to get rid of any unnecessary moving parts. I tend to constrain my ideas to things that can operate with as few moving parts as possible, because like I like to build things that last more than like a decade, and the more moving pieces you have to maintain for over a decade, the more exhausting it is, and the more like downtime you have to deal with and stuff like that. So I like to build like these small, very like at least specified systems that will just run on their own for years and years and years without any intervention, which definitely like limits what kinds of problems I can solve. Like I definitely couldn't well, I don't know, but definitely, but most likely couldn't like make an MEV bot that just like runs on its own for a decade and does anything meaningful. But if I were to approach MEV, that's probably the lens I would approach it through, just because I think that's something I'm good at. And also that's kind of like I mentioned in our pre-chat, I like the idea of rather than taking one big risk on one big project, I like to do like lots of little things and then hopefully some of them reach success by building systems that have this kind of endurance and are sufficiently autonomous. It allows me to build lots of little things and hopefully some of them, because like a lot of the time you build a thing, but it's not the right moment for it. And you have to wait years for it to become relevant. Like, for example, my friend and I built this thing called the 1000 Ether homepage in 2000. We're working on it in like late 2017, early 2018. And we launched it in summer 2018, which is like right around when CryptoPunks and stuff launched. But this was like before NFTs were a thing. Like we didn't even have a spec yet. We didn't even have a notion of, it didn't have an API. And it was a cool idea because it was easy to explain. It's like, oh, it's the $1 million homepage on the blockchain. But it wasn't until like 2020 or 2021, I think. 2021, when it became relevant all of a sudden, because NFTs got really big that moment. And then also people were looking for these historic NFTs that are really early. And our project was still like online and active, and like the website was working, the UI was working and stuff like that. And just by virtue of existing for 3 or 4 years, allowed it to become successful. Same thing with like Yearlib 3, like for the first several years, first like 3-4 years, nobody really cared. And then there was kind of a change in the Web2 ecosystem where more people working in Python, everything was HTTP, everything had an API, everything was API mashups. API libraries became like, people started needing to all the big tools needed kind of more efficient HTTP libraries so they could support their users better and stuff like that. So it became more relevant. So it's like, so like timing things are really hard. So I generally try to do some amount of timing, but also I try to like create a very wide horizon of time where things are relevant.
I feel like building a project, I don't know, like the cybersecurity thing I'm doing, the whole goal is just kind of find every exploit possibility, but then it's kind of hard to dumb that down into a simple one. Like, I guess you can do a specific type of exploit and go from there. But I mean, you're going over everything at the same time, so it kind of makes sense to...
Yeah. I mean, I think it definitely makes sense to do a few single, like one-offs just to kind of figure out if you're building the right thing. But then like if I was approaching this, I would try to think through a lens like, how do I figure out a model for what I'm building that will be useful in like 5 years or 10 years? And then kind of what are the missing pieces to make that happen? Yeah.
So like very long term. I think it would definitely, what I'm doing now is definitely doing that. But I think in any kind of one of these smaller tasks, for example, a specific vulnerability, instead of generalizing it, I still need kind of the foundation of the reconnaissance of what specifically do I need to fuzz.
So just for curiosity, like imagine all the things you're currently building, right, have like planned building for the next 3 months. I imagine there was already an open source version of it that you could use right now, and it did everything that you need it to do. What would you do next?
If it did everything I needed it to do?
Yeah, like imagine there was like a a system for like fuzzing arbitrary contracts and like finding, like you could implement your own heuristics and it could crawl all the deployed contracts and like do analysis against them and find if the heuristics match vulnerabilities or whatever. Is that what you would spend your next 6 months on? Just like writing these different heuristics and like hunting down these different contracts?
Yeah, I guess. If someone already built it, then I wouldn't be building it.
Why not? Do you think you can do like a better job or?
I mean, if it was doing what I like want it to do, which is what I'm building, then I wouldn't be building it. It's just it doesn't exist. So that's why I'm building it.
I mean, like, would you use it to do like a higher level thing, or would you work on something else entirely?
I would just work on something else, something on a. Yeah, I'll just identify what they're missing and then build that. Basically.
Okay. Yeah.
Which is what I've been doing. I identified all these tools I don't do generalized auditing efficiently. So I was like, okay, this is obviously something that is missing, and everyone wants it because, okay, first of all, no one wants their protocol to get hacked. They want to see what's possible, and you want to prevent it. So
yeah,
like everybody's aligned. Even like black hats, they want it as well. Auditors want it. Protocols want it. Everyone wants it. So it's kind of like a holy grail if it works.
Yeah, I like that. I think for me, I try to think of it as like a stack. Like I try to regularly ask myself that basically. Like if the thing I'm working on right now, if it already existed in the way that I want it, would I be excited to work on to like build something on top of it? And I try to position myself in situations where I am. If like what's API already existed, I'd be working on like procedurals, front ends, and like other things that use it. And until I'm able to do that in the way that I want to do it, it's not done. It's just because it's kind of it kind of gives you a nice milestone to shoot for that you can actually like. Because like a lot of times like software is never done, as people say, but I don't think that has to be true.
Yeah, I think once you get to a point where you kind of complete your task, you know how to improve it and what else is like missing. So from there, you can keep expanding, I guess, forever until I don't know if it's possible to be perfect, right?
You can always optimize it. You can always make the API better. You can always test it more. You can always like migrate it to a new version of NPM or like whatever you're using.
Yeah, you can try and make it more comprehensive, faster, streamlined. It's kind of like infinite.
Yeah, what I'm saying is like that's like kind of a dangerous trap almost to fall into just improving something without having a higher level goal.
Yeah, as long as you get it working at the MVP, then you can start iterating. But until then, try to get it out. It's the main thing. But yeah, man, it's been quite a great chat.
Yeah, this is awesome.
Thoroughly enjoyed it. Basically just talked about automation the whole time.
Among other things, yeah. Well, I hope that someday I can read the stuff that you built because this sounds really fun.
Oh yeah, for sure. We'll see. Maybe you've converted me to the open source world. Yeah, thank you so much for coming on. We'll probably speak soon as well.
My pleasure. Sounds good. Look forward to it.